The 1950s marked the beginning of a new era in automation with the invention of the world's first industrial robot, Unimate. Conceived by inventor George Devil and brought to life by engineer Joseph Engelberger, Unimate was a groundbreaking creation. General Motors became the first adopter, incorporating Unimate into its production line in 1961. Unimate's success paved the way for a new era of automation. By taking over hazardous and monotonous jobs, robots like Unimate made factories safer. They also allowed human workers to focus on more complex and less dangerous tasks. This invention signaled the beginning of a new era where robots would play an increasingly important role in shaping the future of manufacturing and beyond. The 1970s and 80s witnessed a surge in the development and adoption of robotic arms in manufacturing. As technology advanced, robotic arms became more sophisticated, precise, and capable of handling a wider range of tasks. Car manufacturers, in particular, embraced robotic arms on a large scale. Welding, painting, and assembly line tasks became increasingly automated, with robots working tirelessly alongside human counterparts. This shift not only accelerated production, but also led to improved quality control and consistency. Electronics manufacturing, metal fabrication, and numerous other sectors began incorporating these mechanical marvels into their production lines. The ability of robotic arms to perform intricate tasks with speed and accuracy made them invaluable assets across a wide range of industries. While some feared job displacement, others saw an opportunity for workers to upskill and take on more specialized roles. The turn of the millennium marked a new chapter for robotic arms as they ventured beyond factories and into medicine and scientific research. In the medical field, robotic arms revolutionized surgical procedures. Surgeons could now perform complex operations with enhanced precision and minimal invasiveness, thanks to robotic surgical systems. These systems provided surgeons with a magnified three-dimensional view of the surgical field and allowed for delicate movements with greater control than traditional methods. Robotic arms also proved invaluable in research laboratories. Their ability to manipulate objects at microscopic scales opened up new frontiers in fields like genetics, materials, science, and pharmaceuticals. The use of robotic arms in space exploration also gained momentum during this period. Remote-controlled robotic arms became indispensable tools for tasks like spacecraft assembly, maintenance, and scientific experiments conducted in the harsh environment of space. Cobots, the rise of AI-powered robotic arms. AI-powered robotic arms, or cobots, are revolutionizing robotics. Designed to work alongside humans, they enhance productivity and safety. Equipped with advanced sensors, cobots perceive surroundings and respond to changes. Unlike older robots, cobots don't need safety cages. They handle repetitive and strenuous tasks, reducing workplace injuries. In manufacturing, cobots assist with assembly, packaging, and quality inspection. AI and robotics are ushering in a new era of human-robot collaboration. Space exploration remains a key area for robotic arms. In agriculture, they automate planting, harvesting, and monitoring. Imagine robotic arms assisting with household chores and providing care for the elderly. A new era of collaboration and innovation. The evolution of robotic arms from their humble beginnings as industrial tools to their current and future roles as collaborators, explorers, and assistants is a testament to human ingenuity. As we continue to unlock the potential of robotics and artificial intelligence, we can expect to see even more innovative applications of robotic arms across various sectors. This new era of collaboration between humans and robots presents both opportunities and challenges. It is essential that we approach these advancements responsibly, addressing concerns about job displacement and ensuring that robotic technologies are developed and deployed ethically and equitably. By embracing the potential of robotic arms while remaining mindful of their impact on society, we can harness their power to address some of the world's most pressing challenges, improve our quality of life, and create a more sustainable and equitable future for all.
Hit that like button, subscribe, and stay informed.